Global Finance, Topic 12B, Cash Flow at Risk, copyright Lou Gaddis. In this topic, we'll look at the definitions, implementation, and use of cash flow at risk to measure exchange rate risk. Students will be expected to calculate cash flow at risk and exchange rate volatility. So, we learned in the last topic or last couple topics, that translation exposure is an accounting gain or loss, or a potential accounting gain or loss as accounts get restated in the balance sheet. You measure the exposure by looking at the translation method, which depends on the functional currency for a subsidiary. Once you figure out the net position that has to be revalued, say you're a net receiver of 100 million euros, that would be your V, that would be your exposure. Your gain or loss on that position, say 100 million euros, will be 100 million euros times the new minus old dollar per euro exchange rate. So the old exchange rate would be the one in which the account was booked or currently sitting in the balance sheet. And the new would be the new exchange rate at the time of restatement. An earnings at risk number tries to quantify potential gains and losses. So what it does, it takes the value of the position, and what it's effectively doing here is calculating a change in the exchange rate that has some probability of happening. And specifically, Z is a number to scale the standard deviation of the exchange rate. And you can also scale the exchange rate across time with the square root of time rule for scaling volatilities. Transaction exposure is very much like translation exposure in that it's looking at foreign currencies. However, its focus is on cash flows and not earnings. So for transaction exposure, we don't look at the balance sheet to determine the exposure. We do a pro forma forecast of cash flows. So you're going to still look at, say, receivables and payables and debt payments, but it's not what is on the books, it is what is coming due in, say, the next 3, 6, 9, or 12 months. Likewise, when you do a gain or loss, you take the value of, say, the euros you expect to receive over the next 3 months times the exchange rate when the euros actually come in versus what the exchange rate you expect them to come in. The difference being the surprise, right? The gain or loss. Now, a cash flow at risk formula has the same terms as the earnings at risk formula. V, Z, sigma, square root of time. And it's only in the V that these two positions differ. In translation method, V is a value of the balance sheet items that need to be translated according to the translation method and rule. At cash flow at risk, V is a cash flow estimate in a foreign currency units that you're expecting to net receive or payment. So, CaR, just like EAR, measures the risk that the actual or numbers are different than expected, except cash flow at risk actually looks at cash flows and not earnings. More technically, cash flow at risk is the level of cash flow loss that has some probability of being exceeded over some period of time. For example, a manager may have a 1-year 80 euro receivable and ask how much can the cash flow be different from the expected value with a 95% confidence interval. So in this case, say you expect to receive 80 euros. In 1 year. And you're looking at the forward rate. You don't enter into a forward contract, but you look at the forward rate and you see that the euro's forward price for 1 year is $1.25. So you expect to receive $100. That's the expected in 1 year. So you might ask, the manager may ask, well, what are the chances? What's the probability, or what are the chances that things are going to be different? Or another way of asking it, given some probability, how much can we lose? So we also look in for one more number. We go to Bloomberg and we find that the historical standard deviation over a period of 1 year is 22.5 cents per euro. So that would be my standard deviation annualized of the euro. So now we have an idea that the standard deviation of the euro is 22.5 cents a year, and we're expected to receive 100 or 80 euros. So now we plug in our cash flow risk formula. V is the net position we're going to receive or pay. That's my 80 euros. Z would be from a standard deviation table, statistics table. And if your boss wants 95% confidence for some level of cash flow, you'll just take a look at this table and see that that is 1.65 standard deviations. And the interpretation of that is a one-tailed test, is that if an asset is normally distributed, say price changes of the exchange rate are normally distributed, you would not expect to receive a to see a 1.65 standard deviation change or more against you, an adverse 1.65 standard deviation change. In other words, if I'm looking at exchange rates next year, there's a 95% chance that I will not receive or not see an adverse 1.65 standard deviation change or more. But there is a 5% chance of getting a 1.65 standard deviation change or more. So in this case, my Z depends on my confidence interval X, and then I'll use 165. Standard deviation, say I look up the last 5 years data or go to Bloomberg and look at implied volatilities, and we find out that it's 25.5 cents or 22.5 cents. So then I plug in my CaR. 80 euros times 1.65 standard deviations. That converts the euros into dollars, and I get 29.7. Now in this case, I did something a little bit different. Now I could have taken 80 euros times 165, and if I were using this formula, I would need the daily standard deviation, which would be 0.225 divided by, say, the square root of 260 if you assume 260 trading days in a year. That'll give me a daily standard deviation. And then if I wanted an annual number, I then multiply times the square root of 260. But in this case, I'm going to do a little shortcut, and then I know I need an annual at-risk number. So I'll just skip that and just say it's 22.5 cents. Because in effect, all this second half of the equation is doing is getting you a standard deviation consistent with the time frame you're looking for. So if I'm looking for a 1-year time frame, I need a 1-year standard deviation. I'm already given a 1-year standard deviation. So now the interpretation of this number, $29.7 million. Well, you could then now say that I expected to get $100 from my 80 euro receivable, and I'm 95% confident I will not get 29.7 less than that. But there's also, if you want to be a pessimist, say, well, there's a 5% chance of getting 29.7 less than 100, or 70.3. So here's a simple problem, just like the last one. What's the expected dollar value of a receivable that's 80 euros at an exchange rate of $1.25 with a 99% confidence rate? The daily exchange rate is 0.014 cents, 1.4 cents per euro. And in this case, we're looking for a 1-month exposure. So first we can do the same thing we did in the last problem. I expect to get 80 euros. I expect the exchange rate to be 1.25. So I expect to get $100. So then the question is, well, how much can it be different? Well, we'll just do the cash flow at risk formula. I'll take my V, 80 euros. Since I'm looking for a 99% confidence interval, going back, I can see that's associated with a 2.33 standard deviation times my daily standard deviation, since I was quoted daily numbers here. But I need to scale that to get a 1-month or 22-day standard deviation. So this will give me the 22-day standard deviation. And if you do that, you'll get a cash flow at risk of 12.24. So now we can say that with 99% confidence, I believe we'll get 100, but not more than 12 less than that. So I can say that I expect to get 100. The cash flow at risk number is 12.24. So I'm 99% confident I'll get at least $87 from this €80 receivable. However, there's a 5% chance that I could get less than 87.76 and a 95% chance I'll have more than 87.76. So that's the interpretation of the at-risk number. Now, if this were a payable, the cash flow at risk number is unchanged. Actually, we usually take the absolute value of the position of the calculation, and we'd still get 1224. Just because the at-risk numbers are always quoted as positive numbers. It's just how much money is at risk, whether it's a payable or receivable. It's in the interpretation that it's different. So if this were a payable, I expect to pay $100 to satisfy €80, say, payable. However, there's a 5% chance that I could pay $12.24 more. So there's a 5% chance it'll cost me $112.24 or more to pay off this €80 payable. So we can say in that case there's a 5% chance of it being greater than $112.24 and a 95% chance. I'm sorry, these are both 99 and 1. All right, since this was a 99% confidence interval, my mistake. This is a 1% chance in a 99, and this is a 1% chance in a 99. So again, there's a 1% chance that it's greater than $112.24, and a 99% chance it is less than $112.24. Or I could draw it up here and say, well, I expect to pay $100 for this receivable. There's a 1% chance that it's going to be less than 87.76, and a 1% chance it'll be greater than 112.24. So if you want to talk about a confidence interval, a two-tailed test, there's a 98% chance that it's between 87 and 112. So this is cash flow at risk. One question comes up, since we've studied earnings at risk, EAR, and cash flow at risk, or CAR, which one do corporations use? Well, they generally might calculate both. However, they might get conflicting answers depending on your translation method and the actual cash flow. You could be both long, say, the EAR for the euro and short the CAR for the euro. So which one will dominate when you go to hedging and deciding what to do? And that all depends on what do companies care about. They care about earnings, or they care about cash. So a firm that says has access to contingent funding, like a line of credit. So think about IBM. It could borrow $1 billion in a morning by calling New York, a bank. So they don't really care that much about cash flows. They care about earnings. So for them, they might manage their business primarily with earnings at risk. Also, the adoption of FASB 52, many firms are able to hide many of the earnings gains and losses by choosing the foreign currency as the functional currency and effectively burying the gains or losses in the balance sheet. So that's another reason that firms may, in this case, choose cash flow risk. However, say a small corporation in Pennsylvania who's struggling to pay the bills, they would probably care about cash flow risk. They want to know, what's the probability I'm not going to have enough cash to make payments for payroll next month. So EAR and CAR are both measures of risk for currencies, and depending if you care about earnings or cash, you would choose one or the other as your primary method. There's a lot of reasons why corporations love at-risk numbers, either CAR, EAR, or even VAR, which we might do later. And that is, you can summarize an entire position, say thousands of accounts, with one number. Our net position is €100 long. Also, we like the fact that the at-risk numbers account for the variability of the exchange rates. All right, so the first thing says the advantage is you can summarize your entire company's position to a currency by just getting the net position. The other part of the at-risk formula is you have a standard deviation. So and what this says is if a currency does not change that much, you would then forecast it to be little risk. So the Hong Kong dollar is generally pegged to the US dollar. So you might find the volatility is very low. So you'd see maybe you'd have a large position in a Hong Kong dollar as receivable or payable, but you'd show little risk because the volatility is low. So we like the fact that at-risk numbers account for the historical or expected volatility. And we like the fact that we have this apparatus in mathematics and statistics that allow us to make statements if we make the assumption of normality. So if we make some assumptions of a bell-shaped curve, we can then make statements that a 1.65 standard deviation event would only happen 5% of the time. And then the last thing is we like it because you can scale it across time. My risk of a 1-year position is much bigger than my risk of a 5-day position because there's just more time for the exchange rate to change. And that's why you scale the standard deviation by t. Some people criticize VAR, CAR, EARs because they rely on standard deviations. Whether implied volatilities or historical, they still have to be forecasted, so you have to forecast them. Another criticism is the Z statistic, or the idea that why do you have to assume everything is normally distributed? There's a reason why normal distributions are applied to, say, physical phenomena like human height. Right? We can measure humans and see that an average male might have a mean height of 5'8" or 5'9" with a standard deviation of about 3 inches. So it makes sense that we would only find 1 in 100 human males, 2.3 standard deviations away from the mean, say 6'4" or 5'3". That makes sense because we never really see 1-foot humans or 8-foot humans or 9-foot humans. All right, you never see those 10 standard deviation events in some physical properties. However, exchange rates, you may have an exchange rate that has a mean change of 1 or 2% and a standard deviation of 10%, but every once in a while one goes to 0 or doubles. So that's like finding a 1-inch human or a 100-foot human. So there's a lot of people that are concerned about normal distributions. Also, EAR and CAR do not provide information about how big losses can get. So the idea is you look at, say, a Chilean peso historical standard deviation, calculate your EAR, CAR, and then what you find is, well, I expect the loss to be, standard deviation is 10% times 1.65, so you calculate it. But you really forget that, well, they could collapse, right? The exchange rate could go down by 75%. So by focusing just on the EAR number, you don't really focus on how bad things could get. And sometimes people think that at-risk numbers make managers complacent, which is related to the last number. Well, our exposure is only 5 million. We can't lose that much. Well, you can. So I want to talk more in this topic about translation versus transaction exposure and talk about how CAR is used and compare it to EAR. Also wanted to talk about the pros and cons of using any at-risk numbers, and then be able to calculate cash flow at risk given our positions and volatilities.